Hello students, in today's class of electric current part 4, you are going to learn about different types of circuits. You know that a simple circuit is the one which has a source, a consumer and through conducting wires. So here the source is the battery and the consumer is a bulb which is connected through conducting wires. And the types of circuits are series circuit and parallel circuit. Let's see what is a series circuit. A series circuit is the one that consists of a single pathway through which electricity can flow. This means that a series circuit has a single path, means it has only one path through which electricity can flow. And all the parts of the circuit, that is power source, battery, wires and devices like ammeter and other devices, they are connected along the same pathway. These devices are connected one after another without any branches. So here this sentence means that all of the parts of a series circuit, power source, that is a battery, wires and other devices, they are connected along the same path, means they are connected in a single path, and these devices are connected one after the other without any branches. So they don't divide, in a single path they are connected, and current moves through one device, then the next and so on. So when we are connecting them in a series, that is in a line, when we are connecting, current flows from one device to the next one and so on. So here remember that a series circuit is the one which has only single path for the current to flow. Okay. So here in this series circuit there is a source of current, that is battery, and the consumer is the resistor here. So let's see what it is. A resistor in a circuit is anything that uses some of the power from the cell. So a resistor uses some power, some amount of the power from the cell is used by the resistor. So here which device is using the power from the cell? Bulb is using. So we can say that bulb is also an example for resistor. In a series circuit, the components are arranged in a line one after the other. The point is repeated so that it should be known to you that how the connection can be done. So here in series circuit, the components are arranged in a line, that is in a series one after the other. Now let's have a look at it. So this is the connection of and an example of simple electric circuit. So here in this circuit, cell, that is a source of current, and the resistors, that is two bulbs, are connected in series. So you can observe here that one bulb is connected to the other bulb, and this bulb is connected to the one end of the battery, and the other end of the first battery is connected to the negative terminal of the cell. So here you can see that all the devices and all the components of the circuit, they are connected in series. Like a battery, one terminal is connected to one of the terminal of the bulb, and the other terminal of the bulb is connected to the next terminal, next bulb of one of the terminal, and its second terminal is connected to the positive terminal of the cell. Its a schematic diagram is shown here. That is, bulbs are represented in this way, which you have already learned in the symbols of circuit in the previous class. So these are the symbols for bulbs, and these two bulbs are connected in series. That is, in a line they are connected to the battery. Okay, are you clear? So here it's shown with the three bulbs. The same thing, battery is connected to switch in series, and this switch is connected to the first bulb, and this is connected to the second one, and second bulb is connected to the third one, and the other end of the third bulb is connected to the battery. So in this way all the components are connected in series. So symbolically, this is represented in this way, the schematic diagram of three resistors when they are connected in series. So here the three resistors R1, R2 and R3. These are connected in between the points X and Y here. And these points are connected to through a plug key and to battery. And this battery is connected through ammeter and to the other point of the end X. So in this way, even this circuit is also in connection in a series. Hence, it is a series circuit. Now, let's see what happens in a series circuit. Join three resistors of different values. As you have seen now, R1, R2 and R3 are different values of the resistors. So, join three resistors of different values in series. Connect them with a battery and ammeter and a plug key as shown in the figure. After connecting the three resistors and battery ammeter in a series, then plug the key. Then note the ammeter reading. So you have connected all the components, that is three resistors, battery, ammeter and plug key are connected in series. After connecting, you plug the key. Then note the ammeter reading. You'll get some reading. Then change the position of ammeter to anywhere in between the resistors. Earlier, in the first case, the ammeter is from the battery, is in between battery and the first resistor. After noting down the reading at this position, change the position of ammeter in between the resistor. Then note down the reading each time. That is, when you place the ammeter between the first and second resistor, one reading. In between second and third resistor, one reading. Again in between third resistor and the other end of the battery, again another reading you can note down. Then let's see what happens and what is your observation. It was observed that the value of the current in the ammeter is same independent of its position in the electric circuit. So it was observed that though the position of ammeter has changed, the ammeter reading is denoting the same. It is showing the same reading. Hence, it was concluded that in series combination of resistors, the current is same in every part of the circuit. So this is the key point which you have to remember. When you have connected three resistors in a circuit and the ammeter reading is taken at any point of the resistor, it was observed that the ammeter reading is same, means the current is same throughout the circuit. Hence, we can say that same current flows through each resistor in series circuit. So what is the observation? That is, in series circuit, same current flows through each resistor. So what remains the same in series circuit? Current. Current remains same. That is, same amount of current flows through each resistor in any series circuit. Okay. It can be asked even for a half mark question or sometimes for 1 mark question. What remains the same in series circuit? So your answer should be current. The same amount of current flows through each resistor in series circuit. Now let's see. So here you have observed the current reading. Now what about the potential difference, voltmeter reading? This time insert a voltmeter across the ends X and Y. You have seen the positions X and Y. Now insert voltmeter across X and Y of the series combination of three resistors. Then plug the key again. Note the voltmeter reading. So after you plug the key, note the voltmeter reading. So it gives the potential difference. When you are taking the reading of voltmeter, it gives the potential difference across the 2 points which you are taking, that is between X and Y. Let it be equal to V. Now This time measure the potential difference across the two terminals of the battery. So here second time you have to take the value of voltmeter between the terminals of the battery. So you have to take the potential difference across the two terminals of the battery. So it should be equal to the same because same amount of potential difference flows from the battery to the points X and Y. So this value, let it be equal to V. Now take out the plug key and disconnect the voltmeter. After taking the potential difference across X and Y and across the battery, take out the plug key, disconnect the voltmeter. Now this voltmeter has to be inserted across the ends X and P because we have taken three resistors. So insert the voltmeter across the end X and first resistor. Then plug the key. Again, note down the potential difference across the first resistor. For example, consider it to be V1. Similarly, measure the potential difference across R2 and R3 also. That is across second resistor and third resistor also. So once again, I bring to your notice that this is the circuit which you have considered. That is, X and Y are the points, and in between these 2 points, we have arranged three resistors R1, R2, and R3. These are the three resistors which are taken, and these are connected in series through ammeter, plug key, and a battery. Now, first time we have noted down the difference, potential difference across the points X and Y. These 2 points between X and Y. This value is equal to V. And the potential difference across the battery is also noted down. After then, insert the voltmeter across the points X and P. This let it be equal to V1. Again, separate the voltmeter. Again, connect it across the point Q and S. That is across the second resistor. Let it be V2. The same thing with the third resistor. It should be equal to V3. So, when you have taken the voltmeter readings first time between the points X and Y, it is equal to V. And the next three across three resistors respectively as V1, V2 and V3 are observed. Now let's see the observation after comparing these four values, that is V, V1, V2 and V3. So it was observed that the potential difference V across combination of resistors in series is equal to the sum of the potential differences. That is, the potential difference across the points X and Y is equal to the potential difference across individual resistors. Hence, we can say that V is equal to V1 plus V2 plus V3. So you have to remember that in series connection, the potential difference across the individual resistors is equal to the potential difference across the combination of resistors. When you apply Ohm's law, that is V is equal to IR. So the potential difference across first resistor V1 is equal to I into R1. Similarly, across second resistor and third resistors are IR2 and IR3. And substituting these values in the equation, that is V is equal to V1 plus V2 plus V3, it will be transformed as IR is equal to, since V is equal to IR, it transforms as V is equal to IR, and IR is equal to IR1 plus IR2 plus IR3. Taking out I common from this right side, then it transforms as IR is equal to I into R1 plus R2 plus R3. So from this we can write as R is equal to R1 plus R2 plus R3. So this happens in series connection. Remember that in series connection or in series circuit, current flow is same and the total resistance across the circuit is equal to the sum of individual resistances. Hence, R is equal to R1 plus R2 plus R3. Okay. Now, what is a series circuit used for? So, uses of series circuit. Series circuits are commonly used in strings of lights like Christmas lights. On a festive season of Christmas, the tree is decorated with lights. So, here the connection in which the bulbs are connected is in series. They are used for voltage dividing applications. So, why the circuit is used here, series circuit is used here is, it is used for voltage dividing applications. You have seen that in a series circuit across different resistors, it may be 2 or 3 resistors, voltage across them is divided, like V is equal to V1 plus V2 plus V3. So it was, as it is having the purpose like to serve the division of voltage, it is used for voltage dividing applications like for transistor biasing, etc. What is this transistor biasing? Is like connecting it into DC and all. This you will be learning in your further classes. So what is the use of series circuit is, it is used commonly for voltage dividing applications. And the commonly used circuit where we can observe series circuit is Christmas lights. Example of series circuit. In a series circuit, the same current flows through all components. So, an example of a series circuit is a string of Christmas lights. If any one of the bulbs is missing or burned out, no current will flow and none of the bulb will glow. So here, what happens in a series circuit is same amount of current flows through it. But in case if any of the bulb is missing or burned out, means here any of the bulb is not glowing, which means that current is not flowing, then automatically the other bulbs also doesn't glow. So here the flow of electric current is stopped there. So this is an example of electric circuit in which it is connected. All the components are connected in series. Then other appliances which use electric series circuit are water heaters, well water pump, lamps, freezers and refrigerators. So here other appliances, other electrical appliances which use series circuit are water heaters. Generally we use water heaters maybe for drinking or for bathing, whatever it is. So water heaters, well water pumps, lamps, freezers and refrigerators, all these are connected in series. So when I say that all these are connected in series, it doesn't mean that they are connected in series circuit in electrical like at home. This means that all the parts, all the internal parts of all these appliances, they are connected in series. For example, all the parts of water heaters, all the parts of well water pump, lamps, freezers, refrigerator, all these, their internal parts are connected in series. For example, when you take or when you consider a water heater, the internal parts like the which contains a container or the can, above it the fan and the thermostat, all these they are connected, these are connected in series. Same way in the refrigerator also. So the refrigerant, coolant, compressor, all these they are connected in series. So what are the appliances that use a series circuit is, first example is the Christmas lights, then water heaters, well water pumps, lamps, freezers and refrigerators. All these they are connected in series circuit. These are the appliances which contains series circuit in them. Okay, are you clear here? Let's move on to the next one, that is parallel circuit. So here you have, before to this one you have seen that series circuit is the one in which all the components are joined through a single path. Now, how the components are connected in parallel circuits, let's see. In a parallel circuit, there is more than one resistor, that is more than one bulb, and they are arranged on many paths. So here in parallel circuit, the electrical path is not single, it has many paths. This means that electricity can travel from one end of the cell through many branches to the other end of the cell. So when we are speaking about parallel circuit, it clearly says that the electric current in them travel from one end of the cell through many branches to the other end of the cell. So how the electric current flows is through many paths in parallel circuit, whereas in series it is a single path. But in parallel circuit, it is multiple paths it has. Now look at the illustration which is coming up now. So here in the figure you can see that two resistors are connected to battery, and the current flow in this circuit is starting from the point A, B, C, D through E and to F. So this is the first path through which current can flow. Next, what is the second path? That is, what is the second route or the second way for the current to flow? Starting from the point that is positive terminal A to B and then to C, and after reaching this point, it can start taking the second route. That is, from C, it moves on to G and then to H, to D, E and finally to F. So here there are two paths in the circuit. The first one is A, B, C, D, E, F. And the second one is A, B, C, G, H, D, E, F. So these are the two paths in which the current can flow through it. So from the above, it is clear that electricity from the cell can take either path A or path B to return to the cell. So what we can say is, here when the components are connected in parallel, electricity can take two paths. It can be path A or path B. The great thing about parallel circuit is that even when one resistor burns out, the other bulbs will work because the electricity is not flowing through one path. What is the advantage of having the parallel circuit is, when one resistor, that is when one bulb in the circuit burns out, then the other bulbs continues to work because electricity is having the second path, second route. Like, to reach the final destiny, it has many routes. Here in the previous circuit, you have seen that it has two paths. So one of the path is blocked, it can go through other block. The same thing happens in the circuit. So when one bulb is burnt out, electricity can flow through the other path, that is the second path, and it can continue. So this is the advantage of the parallel circuit. Here is another circuit in which three resistors are connected. So what is these three resistors and how they are connected is, here when you see a circuit, first you should be able to identify which circuit it is, whether it is series or parallel. How can you identify? By observing the terminals connection. If all the ends of the terminals are connected to one point and the other ends of the resistors are connected to another point, then we can say that they are connected in parallel. So here you can see that the resistors R1, R2 and R3, their left ends, the left terminals are connected to the point A and the right side terminals are connected to the point B. Hence we can say that these are connected in parallel. And these two terminals A and B are connected to positive terminal of the battery and the negative terminal of the battery through ammeter and plug. Hence this is a parallel circuit. And this has three parts here. In the previous circuit, the circuit has only two parts, two ways to flow, whereas in this it has three ways. What are they? Let's check out. Starting from the point that is the positive terminal of the battery to A, and after reaching A it can go through R1, B and ammeter, plug key and the negative terminal. Okay, the second route is positive terminal to point A, and after reaching A to R2, from R2 to B, ammeter, plug key and the negative terminal. This is the second route. Whereas the third route is from positive terminal to A, R3, B, ammeter, plug key and the negative terminal. So here this circuit has three parts, that is three routes for the current to flow. Now consider parallel combination, and let's see what happens in a parallel combination. Make a parallel combination XY of three resistors having resistances R1, R2 and R3 respectively. You have seen just now, like three resistors when they are taken, consider their resistances as R1, R2 and R3. And these three resistors are connected between the points X and Y. Connect them with a battery, a plug key and an ammeter. Then an voltmeter is also connected in parallel. As we know that voltmeter should be connected in parallel. This is connected in parallel with the combination of resistors, not through a resistor, through the combination of all the three resistors. Now plug the key and note the ammeter reading. So here, when the three resistors are connected in parallel and voltmeter is in parallel connection with the combination of resistors, note down the current. Let it be I. So this is the circuit. The points X and Y, and in between these two points, three resistors R1, R2 and R3 are connected. So here this circuit has the three parts. Since three resistors are there, three routes are there. That is from positive terminal to X, L, M, Y, A, key, plug key and to the negative terminal. The second route again from the positive terminal X, P, Q, Y, ammeter, plug key and negative terminal. The third route is positive terminal again, starting from it, the point X, S, P, Y, again ammeter, plug key and the negative terminal. So after connecting all this, note down the potential difference using the voltmeter across the combination of resistors. So here the voltmeter is connected across the combination of resistors because it is connected at between the points X and Y, and X and Y is a combination of resistors. So here the voltmeter reading V gives the potential difference across the combination of resistors, and ammeter gives the position of ammeter here denotes the current reading across the combination of resistor, which is noted as I. Also take the voltmeter reading, which gives the reading as V, which we have discussed now. Now check the potential difference. Check the potential difference across each resistor. So in the circuit you have seen that the voltmeter is placed across combination of resistor, and the reading is noted down, which shows V. Now change the position of the voltmeter across individual resistors and note down the potential difference. Then it was observed that the potential difference across each resistor is same. So here when you are placing this, you should have to observe and listen carefully. When you are placing the potential difference, when you are placing the voltmeter across combination of resistors, it was found to be V. Then after this, when the voltmeter is placed between individual resistors like resistor 1 and the point A, X, it was found to be V. And when it is shifted to the second resistor, there also it showed the potential difference as V. The same at the resistor 3, that is at the third resistor. So with all these three observations, it was found that the voltage across the individual resistors is same in parallel circuit. So in parallel circuit, the voltage across individual resistors remains the same. So you have to note down a point here, that is, in parallel circuit, the voltage across individual resistors, it may be across R1 or R2 or R3. The voltage across individual resistor remains same, whereas in series, current remains same. In parallel, voltage remains same in parallel circuit. Now let's continue this activity. Take out the plug from the key. So you have observed that the voltage across individual resistors is same. Now take out the plug from the key, remove the ammeter and voltmeter from the circuit, and then insert the ammeter in series with the resistor. This time you have to change the position of voltmeter and ammeter. Where ammeter has to be placed is with the first resistor, and note down the reading. Let's see what it is. So here, when the position of ammeter is changed, earlier it was down near to the battery. Now the ammeter has shifted to the first resistor, near to the first resistor. Ammeter is in connection with the first resistor in series, and voltmeter is across the first resistor. So here, when the ammeter is placed across the first resistor, it was observed that the current reading is I1, and when it is placed at the second resistor, it was found to be I2, means the ammeter is shifted from here to the second resistor and the current was observed to be I2. Then it was shifted to, the ammeter is shifted to the third resistor and current was observed to be I3. The current reading is I3. It was observed that I is equal to I1 plus I2 plus I3. So applying the Ohm's law, that is V is equal to IR. I is equal to V by R. So here I across the circuit is equal to V by RB, and I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. So substituting these values in the first equation, we get that V by Rp is equal to V by R1 plus V by R2 plus V by R3. Taking out V common from this, we get V by Rp is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Cancelling V on both the sides, we get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this equation concludes that the reciprocal of equivalent resistance of group of resistances in parallel connection is equal to the sum of reciprocals of individual resistances. I remind and repeat the point again. The reciprocal of equivalent resistance of group of resistances in parallel is equal to sum of reciprocals of individual resistances. Now let's see the purpose of parallel circuit. A parallel circuit has one function, that is to keep the electricity flowing when one pathway is interrupted. So what is the function of the parallel circuit is, when one pathway of the circuit is interrupted, means that is blocked or disturbed, the flow of current continues through other path. So this is the advantage of the parallel circuit. A prime example is light fixtures that use multiple light bulbs. So when a single bulb in the fixture goes, the light fixture continues to operate. So when we are using multiple light bulbs, though one of them blows, the other lights continues to glow. So this is the advantage of the parallel circuit. So an example of parallel circuit is the wiring system of a house. So here you should observe that in our house all the wiring system is done basing on parallel circuit. Just imagine what happens if the wiring is done in series. So when any switch is on, all the home appliances are connected in series. So though you are in a one room, if you switch on the fan of the room in which you are staying, the other appliances, it may be a fan, bulb of your room and the other room also works. So this is the disadvantage. Due to that, all the wiring system is done in parallel in a house. So a single electric power source supplies all the lights and appliances with the same voltage. What is the use or the function of the parallel circuit is when single electric power supplies, it supplies all the lights and appliances with the same voltage. So the same voltage is supplied through all the appliances in parallel circuit. If one of the lights burns out, current can still flow through the rest of the lights and appliances. Now let's see what are the advantages of parallel circuit. The main advantage of the parallel circuit is that consistent voltage. That is, they maintain same voltage. A constant voltage is maintained among the circuit. One of the advantages of parallel circuit is that they ensure all components in the circuit have the same voltage as the source. So what is the use of parallel circuit? What is the advantage of the parallel circuit is that the components which all are connected in the circuit, they have the same voltage as the source. For instance, all bulbs in a string of light have the same brightness. Since the voltage is same, the amount of brightness is also the same in string of lights. So here when we are speaking string of lights, immediately the Christmas lights clicks in our mind. So when you compare the connection of that and this, nowadays the Christmas lights are available in two-way of circuits, that is in series as well as in parallel. But how can you differentiate is that these circuits which are connected in parallel, they have thread based at its bottom of the bulb. So that is the cards C9 and C7. Easily with the help of this thread based base, you can identify the parallel circuit. Whereas the series one, it is the bulbs which are connected one to the other end of the bulb in series. So we can say that the main advantage of the parallel circuit is that they ensure all the components have the same voltage in the circuit. So this is the advantage. Then what is the difference between parallel and series circuit? We have learned that circuit connection can be in two ways, series and or in parallel connection. So what is that? What is the difference between them? A series circuit is two or more elements connected end to end. In a series circuit, the components or the elements, they are connected end to end. That is one end of the first component to the other end of the next component and so on. So this is about series circuit. Whereas in parallel circuit, two or more elements with each terminal connected to the corresponding terminal of the next device. In parallel circuit, how it is done is two or more elements with each terminal, that is either left terminal or right terminal or one end or the other end. So all the corresponding ends are connected to the next device and the other terminals are connected to the corresponding terminals of the next device. So in that way, same voltage appears through each element. So this is the difference between series and parallel. Shall we recollect? Series circuit is the one in which all the components are connected end to end and same amount of current flows through it. Whereas in parallel circuit, the components are connected with each terminal connected to the corresponding terminal of the next device. How they are connected? Each terminal connected to the corresponding terminal of the next device, and they maintain same voltage across each element. So this is the difference between series and parallel connection. Let's recap once again. Series circuit is the one in which all the components are connected end to end, one after the other, and they form a simple loop for the current to flow around. So when series circuit is there, so there is a simple loop and single loop for the current to flow around. If one bulb blows, it breaks the circuit and all the bulbs also go out. Whereas in parallel circuit, the components are connected side by side. So here you can see that how they are connected. These two are the bulbs or resistors. These two are connected side by side. The corresponding terminal, left terminal of the first one is connected to the again left terminal. These two are the corresponding terminals of both the resistors. They are connected to the one end, and the other corresponding terminals are connected to the other end of the battery. So this is a parallel circuit. And in parallel circuit, the current has choice of routes. It has choice. It has many ways to go, many paths to flow. And what happens in parallel circuit is, if one bulb blows, there would still be a complete possibility to the other bulb to glow, and it stays lit, means it glows. Now, what happens in a series circuit? In series circuit, current across the circuit remains the same and voltage is shared between the components. That's what we have seen. V is equal to V1 plus V2 plus V3 in series. For example, if you take the voltage across the circuit is 3 volts, then at each resistor it is at 1.5 volts and 1.5 volts. So the 3 volts of potential is divided between the two resistors as 1.5 and 1.5 in series circuit. Parallel circuit. So in parallel circuit, voltage is same in all the parts of the circuit. That is, here the voltage across the combination of resistors is 3 volts, and in between each resistor is also 3 volts. So the same voltage is maintained in all the parts of the circuit. Measuring current. In series circuit, the current is same at all the points in the circuit. So when you observe the first circuit, here the two resistors are connected in series and the amount of current flowing through them is 6 amperes at all the points. At any point in the circuit, the current flowing is 6 amperes. Now, parallel circuit. In parallel circuit, current is shared between the components. So we know that in parallel circuit, voltage remains the same and current is shared between the components. So moving on to the circuit, here the two resistors are connected in parallel and the amount of current flowing in the circuit is 4 amperes. And this 4 amperes of current is shared between the two resistors as 3 amperes and 1 ampere. So through first resistor 3 amperes of current flows and through the second resistor 1 ampere of current flows. So on the whole, the current is shared between the components in parallel circuit. Okay, till here you have learned about types of circuits, and in the circuits, that if though there are different types of circuits, what remains the same in the circuit and what happens in a circuit you have seen. What are the advantages of each circuit you have seen. Now it's a time for you to identify and use your knowledge in finding out. So here is a measurement of current and voltage. So when you are trying to find out or to measure current and voltage in a circuit, you should do two things first. That is, identifying the type of circuit. Then next, what remains same in the circuit you have to recollect, and then start calculating the quantity which you have to find out. Okay. Now observe the circuit here. Here in this circuit, the two resistors are connected in series because they are end on end connection. So it is in series connection. And in series circuit, what remains same? Yes, current remains same. And how much is the amount of current flowing? That is 4 amperes started from positive terminal. So the amount of current even here also it should be 4 amperes, and even at this point also it should be 4 amperes. So this is the measure of current. Now what about voltage? So in series circuit, current remains the same and voltage is shared between the between the components. So here, what is the voltage across the circuit? It is 6 volts, and this 6 volts is divided between these two components. So how much it should be? 3 volts and 3 volts. Let's see whether we are correct or not. Yes, the current is 4 amperes, and at this point also 4. Here also it is 4. So we are right there in measuring the current. What about voltage? 6 volts, 3 volts and 3 volts. It's divided into 3 and 3. So it's a shared as 3 volts and 3 volts. The next one. Next, another problem, that is, in this circuit, we have to identify first one which type of combination or which type of circuit it is. Here two resistors are there, and these two resistors are connected in parallel because it's not end on end. Corresponding terminals are connected to the corresponding terminal of the battery. So this is parallel circuit, and in parallel circuit what remains same? Yes, current or voltage? Voltage remains the same. And what is the voltage here? 6 volts. So at this point also it should be 6, and even here also it should be 6. Then what about current? So here current is 4 amperes, and this is divided between the two resistors. So it can be 2 amperes and 2 amperes. And finally again 4 amperes of current flows through it. So let's see whether we are right or not. Yes, voltage is 6 volts, 6 volts and 6 volts, since it remains same across any point in parallel circuit. Now current. The current of 4 amperes has started flowing, and it is shared between the two resistors as 2 amperes and 2 amperes. And finally 4 amperes of current flows. So we are right in measuring the current and voltage. So I am confident that you have understood series and parallel circuits. And as you are going ahead in your activities in doing many useful circuits and useful projects, this knowledge also will enhance your skills to modify and to bring out new projects. Thank you. But I want to remind you once again that you should go through your running notes and textbook after the session. Thank you.